Principal DA at AWS for Serverless, Eric Johnson.
All right, thank you. All right, so why did they set up mics? Here's the truth. Usually I use a lapel. I walk around a lot. Can you all hear me okay? I have a voice that carries, so they just want to make sure they're recording. If you ask me to hold a mic, I absolutely can hold a mic, but I will drop it at some point. So there you go. My name is Eric Johnson. I'm from AWS. I'm a Principal Developer Advocate for Serverless. You can see here, there's a couple things about me. Now, before we dive into this, I need to give you some rules about when I'm speaking, okay? Is everybody paying attention? If there's anything you want to hear, it's the rules, because it could go bad for you if you don't follow the rules. All right, so has anybody heard me speak before? Okay, good. All right, 3 of you know the rules. Keep it to yourselves, all right? So this is rule number 1. Ready? This is any number I want it to be. Okay? I may hold this up, I may say 7, I may say 23, I may say 42, but it's any number I want it to be. Now I tell you that because I do that without even thinking. Like I'll go to restaurants and say, hey, I need a table for 7, and I end up by myself at the bar because they're not listening. They don't know the rules, right? Second rule is these are quotes, not apostrophes, and I know that. Okay? This looks a lot better than this, okay? When I do this, someone thinks I'm doing a bunny. Is he doing a bunny? I'm not doing a bunny. Unless I am. It's all contextual, right? And these are thumbs. I do this a lot too. So I'll hold these up, I'll look at you, and that really confuses people. They'll do that. But I do this, because this will get me beat up, right? So you have to be careful with that. I was born this way. I make a lot of one-finger jokes. I'm very comfortable with that. However, if that makes you uncomfortable, I'm also comfortable with that. So I'm good to go, all right? All right, so let's get started. Again, I am from AWS. You can see here I'm a Principal Developer Advocate. I've been doing serverless since the day they announced it. I remember, of course there was stuff before Lambda, but I remember when they came out with Lambda and I went, wow, duh. Why would you do it any other way, right? And so I remember looking at that. I am a dad of 5. How many? Okay, good. All right. There's latecomers going, that's a 1. So, yes, I am a dad of 5. My wife is a superhero. That is not a typo. I am a pizza lover. If you hear anything about me, I talk about pizza a lot. I do not believe there should be pineapple on pizza ever. So, there we go. All right, there we go. Sound guy agrees. So, I'm a drummer. That used to say musician, but then I got a lot of people going, really? Is that a musician? So, I'm a drummer. So, I know, and you're probably looking at me going, drummer, huh? Yes, I am a drummer. I went to college playing drums. Here's what I learned, okay? Turns out I'm a phenomenal drummer for one finger. Past that, I'm pretty average and nobody's gonna pay me to play. So, had to do something else. And finally, I am all things serverless and EDA. And that's what we're gonna be talking about today, but we're gonna be talking about in the world of GenAI or artificial intelligence, right? So we're going to talk about practical. I'm doing, Alex got to do the fun stuff. I'm going to do the more practical. It's not sexy. It's just, the practical. So we're going to talk about what does it mean. Now, when we think about AI, so Alex gave a phenomenal overview of GenAI. I kind of had some of that in my deck. It wasn't near as good. I ripped it out. I was like, Alex, great job. So thank you, Alex, for the setup. I appreciate the opener, buddy. I don't know where he is, but yeah, there he is. Okay, he left. Eric's on him out. So no, he's right back there. So, but I want to talk about what I think are the phases of AI, right? I'm not going to talk about the curve, the fancy drawing he had, but what we kind of think of when we think of AI, what are we working with, right? And it really breaks down to 3 simple ones, right? You have design. Okay, this is where people are. I'm going to write that algorithm. Okay, I'm going to and that kind of stuff. It's math that I can't even spell. Right? The second part of it is training, right? So we spend time training that. When you look at these, the ChatGPT and all the other stuff, and it's dumping, it's exposing it to a lot of data to modify that. And finally, it is inference, right? Or using. And I posted this tweet here about a month and a half ago when I was preparing actually for this. And here's what I said, and I really do believe this. I said, the more I dig into AI, ML, and GenAI, the more I'm convinced that for 99% of us, it will just be an endpoint. Now, I'm not trying to belittle it. I'm not trying to say, but it will be simply a consumption point, right? And it's something that we do. And how effectively you use that comes down to, number one, data orchestration and choreography. How do you get data to and from the endpoint? How do you prepare your data to run inference? And then what do you do with the data coming back? And the two, prompt engineering, which I agree with Alex. I don't know if we're all going to get a $300,000 job doing prompt engineering. I've tried, but that's true. Is how do you do the prompt? And Alex has some great stuff on that. So with this in mind, I wanted to talk about what does it look like to do practical AI? What does it look like to consume AI services, and how do we do that? And the first thing it comes down to, I think, we had great coverage, is choosing the right model, choosing the right AI. Now, again, I'm going to wander a little bit. Let me know if you can't hear me. When we think about this, there's two types of AI models, and this is just for our purposes. Obviously, there's all these big ones and stuff, but when we break it down, and Alex already talked about this a little bit, and I'm going to reinforce this, it comes down to, one, we have this deterministic model. These are the rules and stuff that we train it, and it may create more rules as it's learning, but these rules are created and it's deterministic, right? And what that means is, and the other one, sorry, let me say this, is probabilistic or stochastic. All right, I'm sure I say that wrong. But probabilistic is this idea of probabilities, right? And that's going to change. And so that comes down to, with the deterministic, each attempt, if I have the exact same data against the exact same rules, I'm most likely going to get the exact same responses, right? Because those are the rules we've set up. This is like, we have, at AWS, we have different services that are made to do this, like textract or comprehend or different things like that. And then with the probabilistic ones, you're not going to get the same answer every time. How many of you put the same prompt in to your Stable Diffusion or Midjourney, and you get different pictures back? Right? So they look different each time because it's changing the rules of it. It's changing its data behind the scenes. And so, and as Alex was saying, that can be not tough to work with, but it's something you have to understand when you're working with that. So when we're choosing the model, how do we apply each one of those? And the reality is with the LLMs we have now, it's like, that's the go-to first. And I think Alex has great advice. When you're talking about this, you're looking at these summaries and things like that, that's the go-to. But sometimes a specifically trained model makes more sense as well. One that's specifically trained on your data, like a Mocon robot. What do you call them? Mo robot, whatever, they're not listening. So anyway, yeah, but like that Mocon robot they're doing, it's specifically trained to do this kind of data, right? So what I want to do today is kind of talk about real-world applications. Now, if you're familiar with our team, there's a guy named David Boyne on our team. Anybody know David? All right, good. Nobody. That's good. So look David up. All right, he does some really cool EDA stuff, and he built this application that every night, he has two little boys, every night it goes out and it uses ChatGPT, and it creates a story. And he gives it context. It's got his kids in the story. And then it takes a story, and then it goes over, I think he's using Dolly for this, and it creates the images to do the story. And then it creates a website, and then he sits down and he reads that to his kids every night. Yeah, it's an incredible thing. He did this quite a few months ago, and we actually did this demo, and that's really cool. But what we're finding is companies are saying, yeah, but I need to do more than that. I need to do stuff that's not as cool as that. I need to do practical, and how do I apply that? So it all goes back to a dentist appointment for me. So several years ago, I was sitting in a dentist office, and this dentist said to me, he knew I worked for AWS, he knew I was technical, and I know anybody, developers, anybody technical in the room, anybody finds out you're fixing their printer before you want to, right? So he's like, hey, I got a question for you. He said, I have all this data that we've scanned, and it's actually in image format sitting in storage. And I'm talking thousands upon thousands upon thousands of them. And then we add more all the time because that's how we archive our reports, our surgery, or not surgery, but I guess some surgery, things like that. That's how we save that all, but we can't really search it. We can't really refer back to it. We can't use the data. And at the time I was like, oh yeah, that's rough. Have a good day. Where are you going to drill? and we moved on, right? But as we started looking at this, I was thinking, there's a way we could do that. There's a practical way to use generative AI to do this. So let me show you what we have. So we've got this job we want to do. Okay, it's a medical transcriptions job, and basically many medical institutions still have medical records stored in non-searchable or referenceable formats. So we're going to build an application to fix this, right? So the images, they can be scanned images, they can be audio recordings, they can be PDF docs, they could be chiseled on a tablet, we don't know, but there's a lot of different ways that this data is stored. And we have 3 requirements, okay? Number 1, I need to convert the current format to text. Number 2, I need to summarize the text. And number 3, I need to save text to the database, okay? And you all caught that was any number I want to be. Now, I do want you to know, just as a side note, I can get to 4 if I take my shoes off, but it gets awkward for everybody. So that's why we do the 1 number for anything. So, all right, so these are our requirements. But we also have some parameters, right? Number 1, as always, we're a business and we're trying to keep our doors open, so it needs to be cost efficient. Number 2, it needs to be accurate, okay? So I need it to not say, the moon is beautiful on a report. It needs to be accurate on the report. Number 3, it needs to be how you doing? They pay me to speak at AWS, shocking. Near real time or daily. And finally, it needs to be HIPAA compliant. All right, so when we think this through, there's several models, and we go, okay, how are we going to apply our AI? Now, I could go right to say, okay, we're just going to do it all in an LLM, right? But I probably don't need to, okay? There's some things that can be done beforehand. So I'm going to look at several. First is I'm going to look at Amazon Textract. Now, I'm choosing Amazon because I use it for AWS, but there are other ones. There are other models that will do this, where you are actually scanning images, and it'll pull the text out of that. So this is a real image. The other one I'm going to look at is Amazon Transcribe, which will actually take audio and convert it to text. And then finally, we are going to run an LLM. The one I've chosen is the Falcon. This is the 7B. It's based on, this is 7B Instruct. It's based on 7B, and this is a Hugging Face open model. In fact, I can show you a little bit here. It is open source. It's a large language model trained on a ton of tokens. It's fine-tuned on a mixture of chat and instruct. So it does what I needed to do. There is a bigger one I could run, but if for practicality's sake, use the one you need, not the absolute best one, right? The one that gets the job done, right? And so when you look at that, and we'll talk about that in the cost format in a little bit. All right, so that's the model I chose. So here's our building of the application. So we have an S3 bucket, and it's got all our data in it. At the end of the day, I want it all in DynamoDB. Okay, so we have our source, we have our target, but we need to do some things to it before it gets there. All right, so we're going to bring in Amazon Textract and Amazon Transcribe, and this meets our first requirement. We have to convert the current format to the text. Now, the cool thing about Textract and Transcribe is you can also train these, right? So you can use them out of the box, but you can continue to train them so it gets more accurate, because that's another one of our requirements is accuracy, right? So you continue to train them, right? Then we're going to summarize. So we bring in running on Amazon SageMaker, which is our AI ML service that you can run that. We actually bring up an endpoint to do this. So it literally becomes, what did I say? An API. Because at the end of the day, most times, AI ML becomes an endpoint for us. So this creates an endpoint that I can call from an API to get, okay? And finally, we save it to DynamoDB. So there's our requirements. Let's look at our parameters. So to be cost efficient, I'm using these services. Amazon Textract and Transcribe are serverless, and they're pay as you go. We'll talk a little bit more about SageMaker in a little bit, but that one I can run. I can try to minimize the model that I'm running for size. For accuracy, again, I'm using the one that's going to be accurate enough, right? I don't need to go to the biggest one. And then the near real time or daily, and how this is going to work is that I'm actually going to drop a file into Amazon S3, and that will trigger the process, right? And then finally, it's HIPAA compliant. So all the services we're using are HIPAA compliant. Also, and you may be asking yourself, Eric, there's several third parties that you can use for this. Yes, that's true. But one of the things when we talk about building applications, we build them with compliance around it, is the more I have control of the endpoint, the more I know about its compliancy, the more I know about its reliability, the more I know about its cost. So I'm bringing all that into my system. All right, so, and then how the data is orchestrated determines how fast we can do this and still be cost efficient. We're gonna look at two ways of doing this, okay? The current way, again, is on demand. So the way I'm gonna do that, so let's look at data orchestration. So we've got our services. I'm gonna actually use AWS step functions, and here's how it's gonna work. When a file or a recording or something gets dropped into a bucket, it's going to kick off the step functions, okay? Then what we're gonna do is I'm gonna use direct integration. If you're not, anybody using step functions in the room? Okay, great, a lot of you, good. Are you using direct integration with the SDK? Okay, a couple of you. All right, if you're not using that, I heavily encourage you to do that because I can talk to all these services directly using the SDK. Then I'm going to use the Lambda function because there's a couple things I need to do that is actually compute. I'm not routing with it, but I'm using it for compute. I have to figure some things out. Okay? So this is what this looks like in step functions. You can see I've got a Lambda function that does determination on the kind of file and some metadata about it. And then it actually kicks it back to step functions. And then if it's audio, we handle it through transcribe. If it's text, we handle it through texttract. Okay? And it goes through, and then it finally saves it to DynamoDB, and it does this process for every single file. So let's go back to our parameter of cost, right? So one of the things we want to look at is, what is this going to cost us? Now, I'm sorry, I'm going to close this. There we go. All right, so when I'm running these services, a lot of them are going to be serverless. Now, if I take and I ask everybody in the room to define serverless. Most likely, I'm going to get, however many people there are in here, definitions of serverless, right? So when we think about serverless, even at AWS, we've got some fuzziness on exactly what serverless is. But when I think of serverless, this is where I'm going with it, okay? Much like what Mokan's talking about, is you don't manage the services, right? At the end of the day, you only pay for what you use. You don't manage the service. We automatically handle all the scaling for it. We handle all the on-prem security, security between systems, right? Now, a lot of times people say, oh, it's serverless. I can just throw code in there, it's secure. No, you still have to write secure applications. You still need to do authentication, authorization, IAM, all those fun things. But we handle all the infrastructure security, things like that, right? So when we talk about these services here, these are serverless, texttract. Only pay for what you use, right? You send it, you get that one-time charge. Same with transcribe. Step functions, you only pay for the step functions and then the transitions, right? And then AWS Lambda, invocations, finally DynamoDB for storage and reads and writes. Okay, so that's how the pricing model is. And so with this, I didn't add this up because there's a lot of variables, and so I didn't want to throw out a number and someone says, well, this is what Eric said it would cost. Right, there's a lot of variables in storage, and what size of the job you're doing. But the basic idea is you're only going to pay for what you use. But let's look at the SageMaker part. Okay? So, remember what I said with SageMaker, what I'm creating is an endpoint, right? So with SageMaker, that endpoint is literally a huge or fairly large machine that's loaded this model, and it's trained already, and it creates an endpoint. And I was saying 99% of us, that's mostly what we're going to use when we talk AI ML. And this endpoint is available all the time. So I pay an hourly rate. This particular machine is $1.51 an hour. So for daily on 24 hours, $36. Monthly at 30 days, it's $1,090. And yearly at 365 days, it is $13,200. Okay? $13,000 to run an inference machine is actually not too bad. But this is a fairly average one. This isn't a huge one, right? This isn't going to handle the traffic that like ChatGPT has taken or Midjourney has taken. This is more internal use. And the way I've got it, it's kind of interesting. The way I'm running this job is I'm throttling. So let's say I have 1,000 objects in the bucket and they're all running. Then I'm going to throttle it out using step functions. I'm using distributed map and saying, just do a couple at a time. With step functions, I can run thousands at a time. I mean, I just hammer away at it and watch my machine go, poof, right? watch it fall down and go, I gave it a college try, but I can't handle all that. So I need to throttle that. So I have that control, right? I could use a bigger machine, but again, my parameters, I really need to be as efficient as I can. So what are our options? What do we do? And this is as I was thinking of this, how do we handle this? And I said, but wait, can our SageMaker endpoint be on demand? Now, some of you may have heard of, we have services, Bedrock. I'm old and I have 5 kids. Their names are 1, 2, 3, 4, and 5, okay? I don't do good with names. And it's always funny when you come up to a service, the service is there in my head, tell them to say it, then it jumps out. But we have a service, Bedrock, that it's not widely available yet, but we're slowly rolling it out. That's gonna handle a lot of this for you. But right now you don't have access to that. So how do I make SageMaker on demand? Well, this is where the power of step functions comes in. So what if we take, and I generated this with the AI as well. All the pictures in here were generated with AI. I was having a good time with that, so it was fun. What if we said, instead of doing it on demand, every time a document's dropped in on the bucket, I kick it off and I do it. Instead of doing that, what if one time a day, I processed all the ones from daily? And remember, I said it needed to be on demand or daily. Okay, so now what I can do is using the direct invocation, I can actually create a SageMaker config, endpoint config, and I can deploy that with step functions. I can have step functions wait till it's deployed, then I run all the work, and then I shut it down. Okay, so you look at this, and basically I'm taking what we did earlier, and I'm wrapping it, and I can do it with step functions, things like that, and I'm wrapping the workflow with something to open. And if you notice here, I'm doing a loop, okay? So what I'm doing is I'm saying, start that endpoint and then check it. And it takes it about 10 minutes to come up. That's a big machine and a big model and a lot going on. So I say, is it up? No. Is it up? No. Is it up? And then, yep, it's up. Okay, do the work. And then I grab, using distributed map, I grab all those files, I do the work, and then I shut it down. Okay, so what does that cost? Now you can see here, I was talking about the different process, the invoked with scheduled event, and I kind of want to walk through this. So I invoke it with a scheduled event rather than an on-demand event, right? So I say at this time, every day, or these 2 times, and I'm using EventBridge schedule to do that. Then I start the SageMaker, I check, like I was talking about, I check every 30 seconds or every minute, however I want to set it. I use a distributed map to process them all, and I shut it down. And what that looks like is I run that hourly, same price. So my daily, because I'm only running it once a day, now I'm running it at $1.51 a day. So monthly, that's $45 a day. And yearly, that's $552. Now the interesting thing here is that's a 96% yearly savings. So the idea here is AI is a big part of applications we build, but a lot of times we shy away from them because, I can't afford that. I can't, that's gonna be too much for our company. We're a startup, right? But the reality of it is for most of us, AI, GenAI, machine learning is going to be an endpoint. We may train it some. Yes, we get into that, so you move into the other percentage, but we're going to be consuming generative AI. And we could do it on our dime, or we can do it on our schedule, right? So we don't have to say, look, it's either all or nothing. I have to pay for this all the time. I don't have to do a monthly subscription. And I want to keep it. Remember, we talked about being HIPAA. I need to keep that in my own account. I need to keep this all under my purview. So I'm able to do this on my schedule as I need it and save quite a bit of money. Now, the results. This is an actual one that looks like, you can see I had a surgical, this isn't a dentist one. I didn't, this is just dummy data. So, and you're looking for dummy data on the internet. I need dummy dental data. This is what I got. So you can see, basically, you have this report of bullets, and then you now have a summary, okay? And so the LLM, so we extracted all the images, we extracted all the text from the image, we sent it to the LLM, it summarized it. This is now in a database. I can search across these, I can put it in, I can do all kinds of things with it. So there's a lot of power to be done there. So let's go back to Bedrock. So what about Amazon Bedrock, right? So Amazon Bedrock, if you're not familiar with this is going to allow you to run a lot of different models. and it's going to allow you to run them as needed. You send an API, you say, I want this endpoint, and I want this, you send it to the endpoint, I want this model, and here's the prompt, and here's what I want you to do, here's the context, here's some different parameters, give it back to me, right? So you could get images back, you could get text back. You see, these are just some of the models. These aren't all of them. But some of the models that we're running, Anthropic, the Stability AI, of course, Amazon's Titan, Jurassic, lots of different ones that can be run. So when you're choosing, especially on AWS, I would look at using this first. This is your go-to, right? But not over, you still have your tech extract. You have your things that are already, I guess what I'm saying is don't reinvent the wheel. Hey, I'm going to train, Amazon Titan to do, tech extract or something like that when it already exists. Take these highly trained, highly focused models and use those first, and then you go to the LLMs like Alex was saying. So that's, again, with the Amazon Bedrock. This is in preview. We have thousands of customers that are already using it. And soon you'll be able to look at it as well. So you see the announcements. We also, and this is great. So I had built the AI stuff to handle the medical transcriptions, things like that. And then we just released a service on Bedrock that has that all rolled into itself. So what I'm doing will be in Bedrock without even having to build that all out on an endpoint. Thanks, Amazon. So, all right. So here's the takeaways. This is what I encourage you. When you're thinking through this, for most of us, AI, like I said, artificial intelligence is as simple as an endpoint, right? You want to use the best model for the job. There are plenty out there, right? Don't try to shoehorn one model for everything. Learn what models are out there. Take some time to learn. I think Alex said it well, that if you're going to be on the edge, if you're going to be alpha, you go out and learn it. This is hard stuff right now. And so you do go out and learn it. Optimize cost through model availability. Don't ever, if you don't have something sit out there and just pay for it without it being consumed, right? So there's a lot of times, especially in our services, you want to shut things down if you don't need them. Think cost, think efficiently, right? Finally, use managed services like step functions, Lambda, and Event Bridge to orchestrate your data. We talk about how do you get data to the AI models. Serverless is a beautiful fit for it. When we talk, we're here to talk about serverless, right? Serverless is a beautiful fit for it. We've got a lot. The step functions, I showed you that pattern. Event Bridge to launch it. You can do containers through Fargate if you need to do some processing for training. It's a really nice fit for it. And I'll answer more questions on that. One of the things I'd encourage you to look at, we always tell people about this. This is a service or a website that my team manages called serverlesslane.com. You'll see a lot of stuff like what I'm talking about, a lot of other stuff. We curate that, put it together, free training. If you're just digging into service, if you're here going, you know what, I'm just checking this out, I'm not sure where to start, this is a great place to start. Finally, a little bit later today, so today I talked about generative AI, and I talked about serverless. But also what I was talking about is a thing called event-driven architecture, right? When we think event-driven architecture, it is this, and I love this statement, not all event-driven architecture is serverless, but all serverless is event-driven architecture. Or I'd say, there's always someone who goes, what about 99%, right? And so it's the idea of I have an event and it starts something. And this is how I define event-driven architecture. When people ask me, and this is very technical, so I'm going to go deep for a minute here. Stay with me, all right? So here's how we define event-driven architecture. Something happens, and we react. I'll say it again. I see it glossed over some of you. It's hard. Something happened, and we react. That's kind of and I know I'm oversimplifying it. There's way smarter people in the room going, Eric, come on. It's not that simple. I'm probably oversimplifying it, but the idea is something happens and we react. Thank you for letting me speak. Have a great day.